Hello everyone, I hope you are doing well. So in today's video, I'm actually going to go through the 2018 Maths Methods Exam 1, short answer questions. And yeah, before we start this video, like always, if you guys want private tutoring, please make sure to, email me down below. I have my, you can see my email here, and yeah, email me whenever you guys want and we can discuss about it. So let's start this video. Okay, question 1. If y is this, find dy dx. Okay, very nice. So 1 mark. So dy dx is, if we bring that 3 in front and find the derivative of the inside, which is what? So negative 9x squared plus 2x, and then write the whole expression again. And just make sure you minus one of those powers. So 2. Perfect. Let f of x equal this. Evaluate f pi. Okay, so this is u and this is v. So what's f dash of x is cos x ex minus ex negative sine x all over cos x squared. And what's f pi? So what? Okay, cos pi is negative 1. E pi, negative e pi, negative sine. Well, sine pi is what? It is just 0 all over, and we know that cos pi is negative 1 squared is just 1. So overall, this is negative e pi. So yeah, that's your answer for this one. And this one is this. Perfect. Let's move on. Question 2. If the derivative with respect to x of the function this has the rule this, given that this is that, find f of x. Okay, very nice and easy. So what I'm going to do is, I can see that there's a common factor of half. So I'm just going to, that f dash of x, I'm going to take half out. It'll become 1 minus 1 over x minus 1. And I'm going to find the integral of that. So I'm going to take the half out. And what's 1 minus x minus 1? Dx, it is half x minus log e x minus 1 plus c. And if we sub in 2, so what's half? So 2 minus log, so 2 minus 1 is 1, so that would just become 0, so we can just take that out. Plus c equals 0. So c is pretty much negative 1. So your overall f of x is, we can say half x, so half x minus half log ex minus 1 minus 1. Is that right? It looks good. Yeah, so it looks very good. Perfect. Let me highlight this. Question 3. If f of x is this, solve this. Okay, very nice. So, cos x, negative half. So when is cos negative? So CA, S, it's over here and over here. So x, well, what's our base angle? Well, our base angle for this is pi on 3. So we will have, from 0 to pi, we have pi minus pi on 3. And pi plus pi on 3. So your x is 2 pi on 3, 4 pi on 3. These are your two x values. Alright. Sketch the graph of the function f on the axis, label the endpoints and local minimum of the point. Okay, so that. Well, we have the x, so 2 pi on 3 and 4 pi on 3, so it's here, here, and what's the range? So it's 1 minus 2, 1 plus 2. So it'll be at 3. And 1 minus 2, which is negative 1. So right over here. What am I doing? Okay, wait. So 1 minus 2 is negative 1. Is over here. So we'll have 3 here. And 1 is it, and we should have also over here 2. By symmetry, we also need to, well, what about if we sub in pi on 3? So if we sub in cos pi on 3, that'll be 2 times half, half. Okay, so it'll be 2. So this over here will be over here, which should be symmetrical to over here. So, and this should be over here because of the range. 1 minus 2 is negative 1. So this graph will look like this. I hope, yeah, it's like, yep. And we need a label, sketch the graph of the function, label the endpoints. Well, this endpoint is 0 on 3, 2 pi on 3, local minimum, pi on negative 1, with the coordinates. That's that. Done. Question 4. Let x be a normally distributed random variable with a mean of this and a variance of this. So your standard deviation is 2. Let z be the random variable with a standard normal distribution. Find the probability if x is greater than 6. So if probability of x is greater than 6, it's just the same as z is greater than 6 minus 6 over 2, which is, what's the probability of z greater than 0? Now you should know by normal distribution that if we always have the mean is 0, and we're saying what is the probability over here, which is just half. Alright, find b such that x is greater than 7 and probably that z is less than b. Okay, so I'm just going to draw a nice graph over here. Okay, like that. And so we know that was 6, so let's say this is 7. So we're saying this over here, and I'm just going to draw this to say this is x and this is z. So this would be 0 over here, and this point would be, so it will be z, it'll be 7 minus 0 over 2, which is half. So this point will be half. Okay, so we're saying that the probability that x is greater than 7, because of symmetry, what is z less than b? So we're saying it should be half also. So it should be at least here too. And that, because of symmetry, this is equal to this. So this over here will be negative half by symmetry. So b must equal negative half. Looks good. Let f be this. State the rule and domain of the inverse. Okay, so we have to say let f of x equal y. Interchange x and y. So that will mean that'll be x 1 over y minus 2 squared, 1 over x, y minus 2 squared, 1 root x. I'll make sure, it's plus or negative, but remember, it's the domain is greater. So we only take the positive, y minus 2. So it'll be 1 over root x plus 2 equals y. So therefore, your inverse of x is 1 over root x plus 2. So that's your rule. Your domain, okay, to get the domain, let's just really sketch this graph over here. Your domain is your range of the function f. So at x equals 2, and we have an asymptote y equals 0, and it's a truncus. But we have to reject, because it says 2 to infinity, we have to delete that part. It's only this part that exists. So our range of f inverse is, well, not a range. Our domain is the same as the range. What am I writing? So our domain of f, dom of f inverse, is the range of our f, which is 0 to infinity. That's that. These are your answers. Perfect. Question 6. 2 boxes each contain 4 stones that differ only in color. Box 1 contains 4 black stones. Box 2 contains 2 black stones and 2 white stones. A box is chosen random and 1 stone is drawn randomly from it. A box is chosen. Okay. Each box is equally likely to be chosen as each stone. What is the probability that a randomly drawn stone is black? So what I'm going to do is I'm going to draw a probability tree diagram, just the most easy. So we say this is box 1, 2, and probability of having black stones and white stones black stones, white stones. Now we know that box 1 contains 4 black stones only, so the probability of success is just 1, whereas this is 0. Whereas in box 2, it contains 2 black stones and 2 white stones, so both have half. And this also is half. The probability of choosing box 1 and box 2 is likely to be half. Okay, it says equally likely. So we want to find the probability that a randomly stone is black. So for black, what do we know? It is half times 1 plus half times half, which is half plus 1 over 4, which is 3 on 4. Is that right? Looks good. It's 3 on 4. Okay. Next question. It is not known from which box the stone has been drawn. Given, so just seeing the word given, I know it's conditional probability. Given that the stone that is drawn is black, what is the probability that it was drawn from box 1? So we want the probability that it was drawn from box 1. So 1 given, well, let me just say box 1 given that the stone is drawn black. So black. So that means that the probability of box 1 intersection B all over the probability of B. Now, box 1 times the... So box 1 and B is what? It's half times 1 all over. And what the probability of black is what? 3 over 4, which we've calculated. So 3 and 4. So we're saying half divided by 3 over 4, which is times 4 on 3, which will be 2 on 3. So, yeah, that would be that. I'm just going to rub this off and just say 2 on 3. That's your answer. Alright. Let B be the point on a straight line this, such that the length OP, the line segment from the origin to P, is a minimum. Find the coordinates of B. Okay. This is a very typical question that I've seen in the past exams. There's many ways you can do this, but I like to, so let's just draw an axis and say, well, the graph has an axis into 0 and it's positive, so it's going like this. Well, really think about it. The minimum means the most least distance. So this is O right here. And, well, here, if it's, let's really look at it. If it's over here, look at the distance, it's very long. But when you a little bit go and go, it shortens and shortens, but we want the most least. When does it shorten? Aha! When it's perpendicular over here, it's the most. Whereas if it goes more and more, it becomes longer and longer. So it really pretty much hits at this point, which is the perpendicular bisector. But we don't even bother with that. Let's just say, okay, we know this point here is 0 and 0. And this point over here, let's say this, let's call it x, 2x minus 4. Some value of x, we don't know. Well, now at least we have 2 points, so we can say that the distance in terms of x is what? The square root of, so it will be 2x minus 4, 2x minus 4, minus 0 squared plus x minus 0 squared, so it's x squared, is equal to 4x squared minus 2x 4 plus 16 plus x squared. We're nearly done, so 5x squared, 4, 8, 16 minus 16x plus 16. Okay, so that's dx, and so d dash of x. By the way, there is an actual cheat. It's not even a cheat, it's a, like, what do you call a tip that you can do. To find a derivative of a square root, the fastest way is, say, for example, you have a function like f of x inside. Well, the derivative of this function, the whole function, is what? It's the derivative of the inside over 2 of f of x. This is an actual rule. So, what's the derivative of the inside? Well, it's 10x minus 16 all over, put a 2 over here, and put the whole function back to where it was. Done. See? And then if we let this equal to 0, what do we get? So we can say that 10x minus 16 equals 0, 16 over 10 equals x, which x is equal to 8 on 5. Okay, we are nearly done. So we have our x value, but we want the coordinates. So we just put this over here. So to find the coordinates, let's put that into that actual function. So that point is, so 2, 8 on 5 minus 4, which is 16 on 5 minus 4, 16 minus 20 over 5, which is negative 4 on 5. So your coordinates of P is 8 on 5, negative 4 on 5. If I haven't made a mistake, yeah, this should be correct. All right, have I made any mistake? Doesn't look like perfect. Okay, find the distance OP. Express your answer in this form where A and B are positive integers. Okay, very nice and easy. Well, we know the distance formula. So if we sub in 8 over 5 in there, it's what would happen? Well, okay, so what would happen is if we take the square root of, okay, so 2 times, so it will be 16 over 5 minus 4 squared plus 64 over 25. This is the square root of, so 16 minus 20 all over 5, which is negative 4 on 5, and we square that, so 16 over 25. So it'll be 16, 25 plus 64, 25. Nearly done. And that overall is what? 80 over 25, which is 5. Well, let's really look at this. If we take, let's say, so 20, because 4 times 2 is 80, and we can take another, so by 5 over 5. So your final answer to OP, the distance OP is 4, 5 over 5. Yeah, that's that. Okay. Perfect. Question 8. So let f of x be this, where k is a positive real constant. Show that f dash of x is this. Okay, so f dash of x, well, this is the product rule, uv. So it'll be x squared k e kx plus e kx 2x. So so what's the common factor here? Well, it's x k e kx. Here will be x. Wait, what am I doing? Well, let's just expand it. Kx. Well, the common factor for all of them is x e kx. This will be x k plus 2. So yeah, same as that. Find the value of k for which the graph of f of x and f dash of x have exactly one point of intersection. So we're saying x squared e kx must equal to x e kx plus 2. Okay, what do we do? Well, these x's will already create a solution, because when x equals 0, that's already a solution. So that's already one solution. So we want exactly one intersection. So that's already one intersection. So what we want to do is now, this will, if we take that x out, so it'll be x e kx equals e kx plus 2. That e kx can get out too, so e kx plus 2. Let's solve for x. So it'll be x minus kx equals 2, x or minus k equals 2. So x is 2, 1 minus k. Now, because we don't want this solution to exist, what way can we do for it to not make sure? We don't want to make sure nothing exists. We don't want a solution to exist because we already have one solution. So for this thing to not exist, we want the denominator to be equal to 0. Because, by the way, we should know that the denominator should never equal 0. But we want the denominator to equal 0 so that we don't have any solution. So this denominator, so 1 minus k must equal 0. So 1 equals k. So k, therefore, is 1. That's your answer. Yeah. Yeah, it just says find the value. So 1 value. Let g of x's be this. The diagram below shows the sections of the graph of f and g where x is greater than or equal to 0. Okay. Let a be the area of the region bounded by the curve of f of x and g of x, and the line x equals 2. Write down a definite integral that gives the value of a. Okay, so your a here is just the integral from 0 to 2 of the upper function, which is f of x. We go up. F of x is x squared ekx. So x squared eks minus your g of x, which is, well, let's put plus now, 2x ekx all over k dx. So that's your indefinite integral. Using a result from pi a, or otherwise, find the value of k such that a is equal to 16 over k. Pi a, what is pi a? Okay. We need to evaluate this integral. Okay. If I multiply this k to all of it, so for example, area is 0, 2, so it'll be k x squared ekx plus 2x ekx all over k dx. And we can take that k out, by the way. What about if we take that k out now? We take that k out. This expression looks very similar to this to this expression over here, if you really look at it. So kx squared ekx, kx squared ekx plus 2x ekx plus 2x ekx. Yes, they look very similar. So, well, this is an actual way we use integration by recognition, if you don't actually see this. But so we can say that the ddx of x squared ekx is equal to x squared k ekx plus 2x ekx. So because we want to integrate this is the expression that we actually have. It's just integrating this, which these cancel out. It just gives us x squared ekx. That's your actual integral. So it's x squared ekx. Perfect. X squared ekx. So we can say 1k e... what was it? E... x squared ekx. X squared ekx. X squared ekx from 2 to 0, which is 1k. So 4e 2k minus 0, this will be 0 anyway, so it's just 4e 2k over k, and that's equal to 16k. So 4e 2k equals 16, e 2k equals 4, log e of 4 equals 2k. Another way, yeah, k is equal to 2. So what's half log e of 4 of k? So log e of 2 equals k. So k equals log e of 2. That's what we get. Yeah, just make this small. So bring this over here. This expression over here. Oops. So log, your k value is a log. It's this expression right over here. Perfect. All right. Log e to k. Part 9. Consider part of the graph of y equals x sine x as shown. Okay. Given that x sine x dx is this, so the integral of that, evaluate this when n is a positive, even, integer, or 0, give your answer. By the way, guys, if you actually, this question was actually, I think it was repeated, because I believe I've done a past exam, like a VCA 2009 or 10. There was a similar question to this. And yeah, there's an actual, a lot of students got this wrong, I believe. So Yeah, I've actually experienced this kind of question in the old VCA exam. So yeah, it's a nice question to have because it really makes you, you need to understand circular functions. So let's get this one done. So it says, given that this is that, evaluate this. Okay, well, because we know that sine x minus x cos x from n1 pi over n pi, and that express, if we very simplify it pretty much, it will be sine pi n plus 1 minus pi n plus 1 cos pi n plus 1 minus, sine pi n pi minus n pi cos n pi. All right, so let's really simplify this. Think about it like this. It says that when n is a positive even integers or 0, so 0, 2, 4, 6. Let's sub in this value. Let's right now look at this expression over here. So pi n plus 1. So if we sub in 0 to n, it'll just be pi. So look at the sign. Let's look at sign. So if we sub in 0, it's pi. So pi is 0. What about if we sub in 2? So 2 plus 3, 3 pi, which is still 0. So it pretty much is 0. So this one over here is always 0. So we can just put 0 there. And we can just finish it off. It's 9 pi n plus 1. So now, we use for cos. Okay, let's look at cos. Like that. Well, okay, we sub in 0. It's pi. What happened? Well, it's at -1. What about we sub in 2 pi? So 2 pi, it's still -1. So it repeats -1 forever. So what do we know? This expression becomes -1 minus. So now the next one is sine n pi. Okay, let's look at the difference. Okay, n pi. If we sub in 0, let's first draw sine. If we put 0, it's just 0, which is just 0. What about if we sub in 2? So 2 pi is still 0. So for sine n pi, it's 0 minus n pi. Now let's try for cos n pi. So for cos, okay, if we sub in 0, it's at 0, it's 1. If we sub 2, it's at 1. So it's always 1. Now, let's simplify this. So we're saying pi n plus 1 plus n pi, which we can say pi n plus n pi equals 2 pi n plus pi, which is therefore the final answer is we take pi 2n plus 1. That's your answer. There we go. So next one, given that this, evaluate this when n is, so it's the same thing, but when n is a odd integer. So odd is, we're dealing with now 0. Oh, no, but here they didn't say 0 anymore. Yeah, so 1, 3, 5. And it has the same expression as we did what we got here. So yeah, I'm not gonna, well, let me just actually copy it. Let me just copy this whole expression over here. And put it over here. Okay. Now let's simplify this. So if we subbed in for sine, so when pi n plus 1. So if we subbed in 1, 1 plus 1, 2, 2 pi. So at 2 pi, it's at 0. Okay, what about 3? 3 plus 1 is 4. So 4 pi, still 0. So this expression here is just 0 minus pi n plus 1. Now let's look at for cosine. So if we look at cosine, so 1 plus 1, 2 pi. So at 2 pi, it's at 1. What about 3? 3 plus 1, 4 pi, still 1. So that means that'll be just 1 minus. Now let's look at n pi. N pi. So let's say we put 1. So it'll be pi for sine. Let's look at first sine. So let's say 1, it'll be pi. Well, at pi, it's at 0. What about if we put 3 pi? Still 0. So we can just put 0 over here. minus m pi. What about for cosine? Cosine. Okay, if we're drawing cosine, if we subbed in 1, so it'll be pi, which is at -1. What about 3? So it's still all -1. So, -1. So simplifying this, negative pi n, negative pi, minus m pi, which will mean that -2 m pi minus pi, so negative pi 2n plus 1. Perfect. Yep, done. That's the expression for this. Are we nearly done? Oh, so left. Find the equation with a tangent to y equals this at this point. Okay, very nice and easy. So what's just dy dx? So find dy dx of this function. So this is u, this is v. So it will be x cos x plus sin x. And if we sub in dy dx when x is -5 pi on 2. So we're saying -5 pi on 2 cos 5 pi on 2, because that negative goes away, plus, actually it will become minus, so minus sine 5 pi on 2. And if we really simplify this, alright, so -5 pi on 2, what's cos, just think of it as cos pi over 2, so cos pi over 2, if I draw cosine, oh no, that's not cosine, it's 0, so just over here becomes 0. So what's then negative sine pi over 2? What's negative sine pi over 2? If you draw sine, it's at 1, so it'll be -1. Perfect, so that's your gradient. Now we have our gradient, it's easy, so it's what's 1 minus 5 pi on 2 equals negative x plus 5 pi on 2, which is y equals negative x, negative 5 pi over 2, plus 5 pi over 2. And these cancel out, so it's just negative x. That's your answer. Done. Alright. Yeah, that's that. The translation, t transforms the graph of y equals sine x onto the graph of this. So, okay, where this is the, so there's only a transformation in the right and left, where a is a real constant, state the values of a. So state the value. Okay, so, okay, let's just expand this. So x dash equals x plus a. So therefore x dash minus a equals x. Let's sub that in. So it'll be y equals x dash minus a sine x dash minus a. Now the problem here is this has negative, it's a negative x. So what we can do is, okay, we can say, if we can take a negative out, so for example, if we take this negative out, so it'll be a minus x dash, now it looks similar to this. And we can also take a negative, so times, out of this one too. So if we say sine a minus x dash, because we can take a negative out of sine. And these, when they're multiplied, so these two negative, will be a minus x dash sine a minus x. So wait, a minus this. Let me just do a different color. So a minus x, so we got that form. Okay. And, well, here, if a is 3 pi, because look at this, if a is 3 pi, let's see what happens. So if we say 3 pi minus x dash, sine 3 pi minus x dash. Now here, this actually simplifies, because think of it like this. 3 pi is like, just say, it's saying it's pi minus x. So pi minus x, which is over here, so CAS. Well, sine is positive, so this expression can be just simplified to sine x dash. X dash, which is here. So it's sine a equals 3 pi. So yeah, it's not too bad. Oh, okay. Let me just make this shorter. 1 mark, wow. I think this should be more than 1 mark, but okay. Last question. Okay, so let's have a look at this. It says, let f of x be this and g of x be this. The line L1 is the tangent to the graph at f, so at 5 pi on this. So at this point over here is pi over 2, 5 pi on 2. And the line xL2 is the tangent to the graph of this at this point, which is pi on 2, negative 5 pi on 2. As shown in the diagram, find the total area of the shaded region as shown in the above. Okay, so what I'm going to do actually is just, I'm going to find the area of this triangle, this big triangle over here. I'm going to find the area of this one of these triangles. And if I find this area of this triangle and double it, we get the area of this whole triangle, the overall total triangles. So let's do that first. And then we can, what we do is then we calculate one of this, like one of the area of these graphs, and then double it and minus them together to get the answer. So first let's calculate the triangles. Well, the triangle, okay, we know 2 points. So this is 3 pi on 0. So let's just find the equation. So if we say y minus 0 and the gradient's 0 minus 5 pi on 2 over 3 pi minus pi over 2, which is 5 pi on 2, x minus 3 pi. So y equals negative x minus 3 pi. So y equals negative x plus 3 pi. So this point over here is 3 pi. Okay, that's good to know. That's all I needed to know pretty much. Okay, so that's 3 pi, and that's 3 pi also here. So our total area of this triangle is, so it's 3 pi times 3 pi. But remember, there are 2 triangles, so we're going to multiply them by 2. And these 2 cancel this half out. So it will be 9 pi squared. All right, now let's try to find the area of the parts here. Let's just try to find the area of this first. So from 0 to pi. Let's try to find that. So what's the area from 0 to pi of the graph 3 pi minus x? So 3 pi minus x sine x dx. Okay, I feel like this is going to be a lot of working out, but let's expand this. So if we expand this, it's just 0 pi 3 pi sine x minus x sine x dx. And I can rub this off and just rewrite it like that, like this. Okay, which is equal to what? So if we integrate this, it's negative 3 pi cos 3x. This over here, we already, so put that minus here. We already know the integral of this, x sine x, from the question above. Yeah, it's just sine x minus x cos x. So sine x minus cos x. All right. Sin x minus cos x. Okay, from 0 to pi. All right, so let's integrate this. So we're saying, okay, negative 3 pi. So if we put, so what's cos 3 pi, which is just cos pi. So cos pi is just negative 1. So put a negative 1 here. Minus, what's sine pi? It's just 0. Minus, what's cos pi? It's at negative 1. This whole thing. That minus, now if you sub in 0, so cos 0 is 1, so it's just negative 3 pi, minus, if we sub in 0 on sine, it's just 0, minus, if we sub in 0, it's just 1. So I'm just going to simplify this, so it'll be 3 pi Oh my god, such a mess. 1, so it'll be negative 1. Plus 3 pi. So plus 3 pi. Negative 1, so 1, negative 1. Okay. I'm scared because I don't know, it's so much algebra and I feel like I made a mistake somewhere. Have I? To double check, I'm gonna just do something here. I'm gonna do this slow actually, because I think I have some time, but okay. Let's really simplify this. Let's really look at this. I'm just gonna make this smaller and bring this over here. Bring this over here. Right over there. Okay. One by one. Let's slowly do this. So, we're saying, okay, negative 3 pi cos. So, okay, if we sub in, what's cos pi? Well, cos pi is negative 1. So this over here will just become 3 pi. Okay, that's good. Minus, okay, sine pi is 0. Minus, cos pi is negative 1, actually. So yeah, cos pi is negative 1. Done. Now we put a minus. Yeah, so we put minus over all this. Minus, if we say what's cos 0, so cos 0 is 1, so it'll be negative 3 pi. Minus, sine 0 is just 0. What's negative cos 0? So cos 0 is what? Is 1. So negative 1. Alright. Okay, so simplifying this now should make our life easier. So 3 pi, 1, so it'll be negative 1, minus negative 3 pi plus 1, 3 pi minus 1 plus 3 pi, okay, minus 1, which is 6 pi minus 2. Am I supposed to do something like this? Is this the long method that I'm doing, or is there like a way to do it quicker? To the shade region. I feel like there's a quicker way, but I'm not seeing it. Oh my god, what have I done? Did I feel like I've made it. Okay. I think I've done something here. Look, I've done a mistake here. I see what I've done here. I've seen it. Okay. Hopefully I've seen it. Here, let's just let me rub this all off. This over here, have I written it right? So, this, so it was 3 pi minus x. Okay, so let's actually just simplify this slowly. So, this will be negative 3 pi cos x minus, well, I'm not going to put that minus. So x sine x, what's x sine x? Integral x sine x. It just, well, let's write x cos x. X cos x minus sine x. Let's just do it this way. So pi to 0. Okay, so doing this, what I'm going to do is I'm going to start doing it quick. So the first one is negative 3 pi. So if we put cos pi, well, it's negative 1. So this will be 3 pi. Plus pi. What's cos pi? Well, cos pi is negative 1. What's sine pi? Well, it's 0. Minus. Okay. So if you sub in cos 0, it's 1. So it'll be negative 3 pi. So this will be 0 anyway. What's negative sine? So it's just 0. Okay. So this 3 pi minus pi plus 3 pi is equal to 5 pi. 5 pi, okay. That looks much better. Now, this is much better. So if we're saying this is 5 pi, let's do the same for the other one. This is an actual quicker method, yeah. We've just found this very nice. Okay, now let's change these terminals. And we're saying from pi to 2 pi. Be careful, but here we have to put a minus sign. Put a minus here. Okay, so we put a minus. Okay, if we sub in, so negative 3 pi. If we sub in 2 pi, so what's cos 2 pi? Well, it's 1. Okay, plus 2 pi. What's cos 2 pi? It's 1. Minus what's sine 2 pi? It's 0. So, okay, so that minus. Now what about this? So negative 3 pi. What's cos pi? It's negative 1. So plus pi. What's cos pi? Negative 1. So this will become 0 also. Okay, so negative. Okay, 2 pi minus, so it'll be negative pi minus 3 pi minus pi, negative pi, negative 2 pi, 3 pi, negative 3 pi, but remember, so it'll be negative 3 pi, but minus the negative, so it'll be 3 pi. So this over here should also be 3 pi. So what's that going down? Well, it's going by 5 pi, 3 pi. So luckily this should be pi because of, the thing is, yeah, it's going down. Remember, this whole gradient is it's going by negative x by negative 1. So it should be going by, yeah, by just pretty much by, yeah, if that's 5 pi, that's 3 pi. This by, yeah, so it's going by minus 2 pi. This should be pi then. So if we know that, so 5, so what's 5 plus 4? So 5, 6, 7, 8, 9. So there's 9 pi. So in total it will be 9 pi. 9 pi, but we multiply by 2. So 18 pi. So the area of that, and then, so the total area is 9 pi squared minus the 18 pi. Alright, that. Wow, that took very long. I feel like there's a quicker method to do this question, but I did not see it. Yeah, I would have done like this. But yeah, there's so much algebra mistakes in this. Like, you got to do it slowly. You know, just, yeah. Wow. I hope you guys enjoyed this video, yeah. Please make sure to like and subscribe. And yeah, if you want more videos like this, yeah, please make sure to support this channel and, you know, give a like and share with your friends. Have a good day, guys, and take care of yourselves. Bye-bye.